Hello, everybody. This talks about our experience talking to MCP servers using small open source models. We're probably all familiar with this, but tool calling's like literally anything where we get a large language model to talk to an external service, be a real-time API for the weather, stocks, news. It can be searching your knowledge base. It can be, if you're a bit less risk averse, it can be using a bash script on your system, or modifying your local file system, or ordering stuff, however much of a chance you want to take, really. And another thing we're all likely familiar with is MCP as a standardized protocol for large language models communicating with these external services. There's open source SDKs from Anthropic for both client side, as in sitting inside the chat client like Claude Desktop or agentic framework, and the server side where you can build your own servers that then talk to your other services. So when the client app talks to, queries the MCP server initially, it'll return with a list of tools, also resources and prompts. That'll have a text description for what the tool does and what it's going to return, and a full JSON schema for every parameter, like with descriptions of the parameters as well. Your big frontier API services will typically abstract the tool calling. You'll just pass in the list of tools, and you'll get some JSON back telling you what's happened with it, telling you whether or not it wants your client app to invoke a tool. With open source models, we often need to work at a lower level. The available tools need putting in the context somehow, usually in the system prompt, and we need the LLM to respond in a way that the client app can parse it. Many small open source models aren't trained for tool calling in any kind of format, and you've got to prompt them and hope that they actually do respond with something that you can parse. MCP is very focused around JSON. We generally find YAML more reliable with small open models, but that's not the way things have gone. Some open models are trained with, and more so now, are trained with a specific structured format for tool calls. This is Kimi K2, the big Chinese open source model. So you can see there that there's something that's not particularly user-friendly to read. It's got that very structured format for how the tool is passed into the model and then how the model is going to respond. And you couldn't use that with some other random large language model and expect it to make any sense of it. Where have I gone? I seem to have lost a slide. Back when Meta released Llama 3.1, they provided instructions for JSON-based tool calling. These are pretty simple, and it works really quite well across pretty much any large language model. It starts with a really plain English description of how to use tools and how it's expected to respond, and then it provides the tool descriptions and schema. Slides have gone really out of order here. Right, so yeah, later Llama and Quen models have kind of trod a more intermediate path. They've been trained for tool calling, but they've used samples that kind of resemble the multi-use prompt engineered tool format that would work across any LLM. Llama 4's here is like nearly 3K of text. It includes like loads of explanations. It includes examples of how to call it correctly, it includes incorrect examples of probably what usually goes wrong. It's big. Quen 3's is more straightforward to look at. While it lacks the examples of the Llama 4 template, it's a lot shorter and in a way easier to read. It's kind of an intermediate case. You can see that there's clearly a structured format there to it, but at the same time, all the instructions are there, and another model could probably follow that if that happened to be passed to something that wasn't Qwen 3. For a universal format to use across any model, we found the Llama templates to be really useful, starting with the short Llama 3.1 template, and then even on models that have never been trained for tool calling, they'll usually follow it, and you can take in some of those instructions and examples from the big Llama 4 template and add them and experiment, and that'll work well across all the different model families. Like Phi, Granite, and even Gemma haven't really been trained with any specific tool calling format. There's nothing there in their templates. Big open models like DeepSeek and, as of a couple of days ago, Mistral 3 as well. They will follow these very, very happily. The latest DeepSeek does have a baked-in tool calling format, though. Go back and show this example that was meant to play earlier. So this is an example of an MCP test server that we made, if it's going to play. Is it? Yes. So this is sort of simulating a soft strings business. You can see there that's putting lots and lots of tool calls, listing what they do and everything, the JSON schema and everything. That's pretty much following the Llama 3.1 template. So that's what ends up going into the system prompts, and then a little instruction there at the end in the normal format. And you'll see that the model just responds simply with a blob of JSON saying, call this. And that's all that's coming back. When we're building an MCP server, because those descriptions and schemas are going to go into the prompts, we've got to keep them concise, especially with smaller models, because a lot of them don't have the massive context lengths of a Gemma 3 or something like that, and also just saving tokens and speed. But there's needs experimentation to strike a balance with making sure enough information's there to select the right tool. Tool selection degrades rapidly the more tools that you add. Too many is often more than about 20 on a larger model. Some of the smaller ones, it can be a lot less, and it really does vary model to model. You can narrow that down by using a RAG-like vector search across your tools to find appropriate ones, or just a clean context large language model call with just listing all your tools and saying, narrow this down to the most appropriate ones, and then including those. Another difference when using particularly smaller open models, they're more prone to going along with bad behavior. This is Llama 3.1 particularly has, if your MCP server simulates control over something safety critical, the user tells it to do something bad, and you'll see that the model just responds with the JSON call to do that thing, but then also outputs some text saying, oh no, I could never possibly do that, that would be awful. So you can't rely on the model alone, and some sort of guard needs to be in place. Why does it matter? Because you could have malicious prompts from one MCP server that you're connected to causing unwanted behavior in another. For instance, if you've got a file server, MCP server active, and you forgot to disable it, and you've connected to some untrusted third party, your prompt injection attack could cause some really bad stuff to happen. Remote servers obviously carry an extra risk that they might be fine the first time you connect to them, but whatever comes back a month later can still be going into your context when other tools are available to it. And if the rug's been pulled on you and that server's been hacked, then again, you're open to prompt injection attacks. We've got another example here where most models do actually refuse if they ask them outright to do bad things. This is Qwen3 Next. Is it going to actually do anything? This is Qwen3 Next from Alibaba. It connects to our MCP test drinks server from before, asked to make a highly addictive drink, and it'll just say, I can't do that, that'd be violating my ethical guidelines, etc. So it's refused, fair enough. However, if you simply tell it that it needs to be a pirate, it just decides to lace the drink with alcohol and opium, and quite happily goes along with it. Which does show that if there was some nasty stuff coming in a prompt from a third-party source, who knows what it might go along with appropriate prompting. Thank you very much. The app that we've used for testing a lot of that, we're going to make available freely soon in the next week or so, and we're going to open source the test MCP servers that we made if anyone wants to have a play with them. Thank you.